and continuing, so what we may want to actually refer to is not page 19, but page 21. Or actually, sorry, both page 19 and 21. Page 19, we have identified that our independent variable is the number of bags of hot Cheetos sold, and the dependent variable in this situation is the money made. Now, a good thing to know is the definition of continuous and discrete data as shown on page 21. And since I can count the number of bags of hot Cheetos sold, and I would not be selling them opened up or anything like that, I would say that our situation is discrete because the number of bags of hot Cheetos can be counted using whole numbers. Number 14 has a key term here, and it would be slope-intercept form. You may want to refer to page 23 for all three forms. Slope-intercept form looks like y equals mx plus b. So obviously I need to find my slope and my y-intercept using just these 2 points. Now, there are various ways to use these 2 points. Of course, you could graph them, which I'm not going to waste time doing that. You could also use the formula for slope or build a table to find the change in y over the change in x. I'm going to start with the first formula, and let's start substituting our y sub 2 minus our y sub 1. And let's go ahead and repeat with x sub 2 minus x sub 1 and simplify. Up at the top I have negative 6, and 2 negatives will become a positive, leaving me with negative 6 over 4, which can be reduced to negative 3 halves. Now I can do this same exact math without getting confused here on a table by first identifying the change in y is decreasing by 6, simply counting with my fingers, and the change in x is increasing by 4, again leaving me with my change in y over my change in x, and I get the exact same answer. Now, that's not the last thing that I needed you to do. I also needed the slope-intercept form equation. I have my slope, but not my y-intercept. Now, the beauty of graphing those 2 points is that I would be able to identify my slope and also my y-intercept from the graph. I know you guys know how to graph 2 points, so I'm not going to waste time with that. I'm going to show you how you can solve for b by using substitution. I already know what my m is, so I'm going to substitute that in. Now, I don't know what my b is, but I have several x's and y's. So I'm just going to go with the smaller of these numbers and substitute in. My y value is negative 1, and my x value is 2, and bring down plus b. Let's go ahead and simplify. I'm actually going to put this over 1 because 2 over 2 reduces to 1, leaving me with negative 1 equals negative 3 plus b, and of course, eliminate that 3 by adding 3 to both sides, leaving me with b is equal to 2. So let's write our final equation in slope-intercept form as y equals negative 3 halves x plus 2. And those are your 2 answers. Number 15. You will again find on page number 23. We're looking for our x and y intercepts, and those 3 beautiful words on page 23 that helps you find x and y intercepts only are hide and divide. So if I wanted to find an x-intercept, I would hide my y term and divide by 2, leaving me with x is equal to 5, but you will get points taken off if you do not write your x-intercept as a coordinate. So to find your y-intercept, I would do the opposite. Instead, I would hide my x value and divide by 4. Now, This time I'm going to end up with a rational number, so please keep it as a fraction. My answer could simplify to be y is equal to 5 halves, which would look like 0, comma 5 over 2. And that's what my two final solutions would look like. Number 16 you can find on, of course, pages 27 and 28, my bad. Now, with this systems of equations, I can use either substitution or elimination, or I could even graph it. Now, just remember, you are not having the calculator on this portion of the test. So looking at these numbers, I probably wouldn't graph it. And I'm not going to waste any time graphing this example. I know you guys know how to graph. So either you know how to graph or you don't. I'm not going to waste time on it. Let's use substitution first. And taking a look, I want to identify the easiest looking equation. I personally think maybe equation number 1, since it has smaller numbers. And I think I will solve for y by subtracting 7x from both sides and dividing by 3. Sorry, negative 3. And I can already tell this is not going to be pretty. Maybe I should have done elimination, but I'm already here. I'm going to go ahead and go through this quickly. I'm going to substitute into the second equation here for y. And I can guarantee you that you will not have giant numbers like I have here, but let's go ahead and next step distribute, which gives me 544 over 3 plus 56 over 3x, and bring everything down. As a matter of fact, I know that I'm going to have to combine like terms next. So I'm just going to go ahead and turn my negative 5 into negative 15 over 3x so that I can easily add these two numerators of 56 minus 15 up, giving me 41 over 3x, and bring everything down just like so. And technically, I would want to go ahead and change the negative 113 into a fraction. But I'll just go ahead and calculate that real quick, because next step is to remove the constant of 544 over 3 by subtracting it. Well, this one will be easy. There we go. So now we can just subtract up our numerators. Yay, things are looking a little bit easier because actually I have 41x is being divided by 3, so that means I can multiply by 3 to get something nice. There we go. So now I have 41x is equal to negative 883. So, oh dear, sorry, I just realized that I did not carry this negative right here. Right here. There. So it would change this right here. I apologize. Hopefully you guys are in pencil. Okay, so I knew that that number was a little too big, sorry. This should actually be 205, 205 divided by 41x is equal to 5. I know you're thinking this was awful, and I agree. I definitely would not use substitution here or graphing. I would use elimination, and I'll get to that in a minute. So I'm coming back through, substituting, and then multiplying, move that negative up, and finally simplifying to negative 11. So I'd like to show you elimination method, which I would definitely use on this one because of the bigger numbers. And I'm going to continue it on the next video.